Number 17. Supersaturated solutions of most solids in water are prepared by cooling saturated solutions. And supersaturated solutions of most gases in water are prepared by heating saturated solutions. Explain the reasons for the difference in these two procedures. Okay, so this question is basically just asking about what's the difference between saturations between solids in water versus gases in water. So we'll put solids in water, and then we'll put gases in water. Okay, now in order to help us out here, I did bring up two charts that illustrate what goes on with gases in water and what goes on with solids in water. The first one on the left, if we look at the components of what the solubilities are, we have helium, nitrogen, carbon monoxide, oxygen, and methane. These are all gases. So this would be gases in water. So the solubilities, as temperature increases, what's the general trend of these lines? Are they going up or are they going down? Yeah, they're going in a downward fashion. So as your temperature increases, as it's getting hotter and hotter and hotter, what's happening to the solubility or the amount of these gases that are able to exist in the water? Are they increasing or are they decreasing? Yeah, they're going down, right? So as you are increasing in your temperature and those temperature values are getting higher and higher and higher, the slopes are decreasing, which means that your solubility of the gas is getting much lower. Solubility of the gases. Now, if we turn to this chart, which is the solids in the water. And maybe I shouldn't say that this is H2O because we don't really know for certain, because they didn't say, they just gave us like a molarity here. But we can assume that since it's gas and water, and this is basically in liquid, water is a liquid, so we're good to go. And then maybe I'll just put that this is H2O. So now let's make a general trend with solids in water. As that temperature is increasing, look at the lines of the solids, right? NaNO3, that would be a solid, that's a salt. NABr, KBr, these are all ionic compounds, except for the sugar, which is covalent. But still, sugar is in a solid form. And as the temperature is increasing, what's happening to the total amount of solubility? Yeah, in this case, it's increasing. Real life example of this is every time on a hot day in the summer, I'm all about iced coffee. So I love to get an iced coffee. However, I always make the mistake to say, no, I don't want any sugar, and then I put my own sugar in it, the actual sugar from the packets. But however, that temperature, it's iced coffee, is really, 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 really cold. So the amount of sugar from the packets that can dissolve is so low comparatively to hot coffee, right? If I increase the temperature of my coffee, you're going to be able to dissolve a lot more sugar in your coffee. But me, iced coffee, I, mistakenly always rip the packets off, throw the sugar in the iced coffee, swirl it around, and then I say, oh, shoot. Everything is at the bottom. All the solids are at the bottom. The sugar is at the bottom. It is not going to dissolve. That's a supersaturated solution. So when in doubt, iced coffee. That's why you need the liquid sugars. You need the pumps, because if it's already in a liquid form, it's going to dissolve. So, little tip, right? And how many more times am I going to forget that? Probably a lot. But see, chemistry is all over. Anyway, increasing temperature for these solids in water, the solubility is going to increase, which means that you can dissolve much more of your solid in higher temperatures for the solids, not the gases, because they are inverse relationship, right? The gases, as temperature increases, the gas solubility decreases, which means that there won't be a lot of gas in those liquids. And another prime example is for global warming, right? As the temperatures are rising, right, and we're talking about lakes and oceans, the temperature of the lakes and the ponds where the fish live, right, it's getting higher and higher and higher. So the amount of oxygen that is in the lakes or in the ponds is going down because your solubility of the gases are decreasing. And for the, all of the species that are living in the lakes and the ponds, it's causing a lot of issues. So just another application. But yeah, basically that's what this question comes down to, right? Supersaturation of most gases are prepared by heating saturated solutions, because when you're increasing the temperature, solubility decreases. And that's how you get a supersaturated solution. You don't want high solubility. You want low solubility. And then on the other hand, supersaturated solutions of most solids and waters are prepared by cooling. That's the coffee that I just talked about. That if we decrease the temperature, solubility will decrease. And not a lot will be able to get dissolved. And that's where you form your supersaturated solutions. So anytime that you're dropping solubility, you have a higher chance of becoming supersaturated, or the solution has a higher chance of becoming supersaturated. And that is it. I hope this helped. Thank you so much for viewing the video. I love helping you guys out. I'm here with you every step of the way. Got a whole chem course just for you, so just keep with the videos. And you got me right by your side, okay? I'm always rooting for you guys. Keep studying hard. Good luck on those tests and quizzes. And I'll talk to you soon, okay? All right. Bye-bye.